Recording is on. Right. Session is now started. Okay. So today the topic is configuring virtual host using Apache as well as playing around with Docker containers. But first of all, before I begin, can you please confirm that you can hear me? You can either speak or just type in the chat area. Hello, welcome Chungu. People, I'm asking, please confirm that you are able to hear me before I can begin.
Hear you.
Okay, thank you very much, Chungu, for confirming. Okay, let us begin. Today the session is on what I'll start with. Firstly, is just talking about Apache, and then from there on we'll move on to talk about Docker containers. So without wasting much time, I think we can begin. So, yeah. Okay, is my screen visible? What's this? I'm sharing the entire screen, so I won't be able to see the text. So if you would, please just speak up. Is my screen visible to everyone?
Visible to me. I don't know about the others.
All right, thanks. All right, thanks for the confirmations. I think what's this right now we can begin. Okay, Apache is by far one of the most widely used web servers, and today we are basically going to look at how to configure a virtual host. Now, before we can talk about how to configure a virtual host, we must know what a virtual host is. Essentially, a virtual host is a portion within the web server that allows us to save multiple sites using one machine. So we can have multiple websites and then save them on the same machine but with different URLs. That functionality in server software is actually called what's this virtual host. That is specifically for Apache. There are other server software such as Nginx where that is called a server block, but in Apache that is called a virtual host. So that is what we're going to look at today. I'm currently running on CentOS 7, which I'm running in my VM. So on CentOS, this file versus Apache is found in etc httpd there. So in here you'll be able to see all the files for Apache. By the way, is my terminal clear? Hello? Just someone to confirm, are you able to see the text on my terminal? All right, thanks. Okay, so uh, let's begin. So when you look at this directory, let me just list everything. When you look at this directory, there there are about three of the major. There's a conf directory. There's confd. Then there's also another one which is conf.modules.d. This is where you find most of the modules that Apache needs. Okay, thank you for the confirmation. So before we actually go anywhere, we'll have to look into there's a directory called conf. This is where you find the main configurations for Apache. So let's navigate into that directory. And once we are here, we find a file called httpd.conf, which is this file I've highlighted here. So let's just open and see what is in this file. Let me just change and then root. So at least I don't have to type sudo all the time. So when you open the httpd file, this is where we find all the server configurations. So at this point, there's server root on etc httpd. It's listening on port 80. There's this part which is talking about the modules that are included, which essentially means it's going into that directory looking for all files that are ending with .conf. So essentially that's what it means. And then this other part talks about this server is running under user Apache, and then the group is Apache. So what this means is if you want to create files that will be under the management of this web server, those files have to be owned by user root, or the person who's actually working with those files, they have to be part of the Apache group. So this is just something that you have to know when it comes to permissions. There's also a part of where it talks about server admin, root, and the likes. Now, this file contains, you can put virtual hosts in this file as well as other configurations, but that is not recommended. The recommended place to put your virtual host is inside the conf.d directory. And as you can see here, it includes this file and looks for every file that ends with a .conf. So to create our first virtual host, we are going to navigate into this same directory, which is one directory above where we are. Then when you list there, we see that there's that directory there called conf.d. So, right, mistake. Uh, so there we are. So in there we find multiple files. There's auto-index.conf, lab.conf, and the likes. So for us to now versus work with any file, we have to create our own configuration. Then the configuration that we create has to end with the .conf. So up until this point, are there any questions, concerns, or anything of that sort? Hello, team. Are there any questions, concerns? I can proceed.
You can proceed.
All right, thank you. So in this file, we'll create a file. So this we use the touch command to create a file, and the file we'll create, we just call it example.com. Now all the files here, for them to be loaded by Apache, they have to end with .conf. So we'll end it like that. So this file that we've created is empty. So we can go on to add what is the parameters that we need to add. Now in every virtual host file contains a text which says virtual host, and then what is you leave a space there. You put an asterisk to indicate that this is listening on all IPs. Now apart from us indicating that the virtual host that we've created is listening on all IPs, we also have to indicate the specific port that it's listening on. Now, by default, web servers listen on port 80, that is for an encrypted traffic. And then for encrypted traffic that goes through SSL, it goes through port 443. But that shouldn't limit you to only using those ports. You can use other ports as well, depending on whatever that is you want. So to indicate the port we're using, in this case, we use the default port 80. So we'll put 80 there. Then this is the what is indicating that everything that's going to go what is here is a virtual host. But a virtual host also has a closing tag, which is specified here. So this essentially tells us that we've now what is declared the body of our virtual host. Now inside of our virtual host, this is now where we need to indicate and put all the configurations that are needed for our web server to work. So the main important parameters that you put inside of a virtual host include the server admin, which essentially is just an email address to the system administrator. In case anything goes wrong, it can be used to contact that system administrator. Then there's also the document root, which points to the directory where the files that are being saved by that virtual host are sitting. Apart from that, you also put the server name, which is a name that is used to resolve to that virtual host. So let's start with analysis by configuring that. So let's put server admin, leave a space, and then you put the email address of the admin. So it can be an email address of the admin, or maybe a broadcast email address for a company. It depends. Apart from that, it also takes in, you can put now the server name, because obviously a web server has to be accessed. This is a named web virtual host we're creating, so somebody has to enter some text, maybe say example.com, and then it has to resolve to this site. So here we have example.com as the server name. So essentially, whenever somebody enters example.com, that example.com will resolve to this site. Now, that same site will not really do anything, because we now have to point it to a specific directory where it's going to get those files that it's going to work with, the files that it's going to save to the end user. So there you use what is called document root. So document root essentially just points to a directory where the files will be stored, the ones that will be saved to the end users. So in there, I say there, so we can also have example. Let's just end on example just like that. So we'll have a directory called example, and this is where what is will store what's everything that has to do with our site, or the files and the likes. So apart from that, you can also define a directory where you're going to store things like errors. You can also define if that directory that you're creating can also be controlled by HT access. So for now, we'll just leave our configuration as simple as that, to only have those things, which essentially is just the server admin, the server name, and the document root. Those will be enough for us to be able to save a simple web page. So we save those configurations. Now, just to make sure, I need to have the address where the document root was pointing to. So let me just check in here. I do not have that. Let me just point it to just the top level, the www HTML, so that we use the default html.index file, which is already here. So I'll go back in here. I'll remove example so that it ends at HTML. Yeah, because in this directory we already have an index.html file that we can actually use as an example. But the way things are right now, if I just go to this same site and then try to type in example.com, even though we've configured our web server, we've not done two things. One is reloading our Apache daemon so that these changes take effect. And then the second one is that this example.com, we haven't set it up in any way to resolve to this virtual host. To do that, to set up this example.com to resolve to this virtual host, there are two ways. One, you can set up a DNS, which is something we are not going to cover. It's something out of our scope. The other one is to use what is called a host file, which is what we're going to do. So we go into etc, and in there, there's a file called hosts. So you open that file, and then you put in your IP address. Right? In this case, because everything is on the local machine, I'll use the localhost loopback ID, which is 127.0.0.1. Then this, I'll have it resolved to example.com. So what I'm essentially doing here is telling a computer that whenever somebody types in example.com, you should resolve that to 127.0.0.1, which is this same machine I'm working on. So if you look at the configuration for Apache, it will come to this same machine. Then the virtual host for Apache will look for this example.com. Then once it finds it in this virtual host, it will resolve all that to this directory. So all that traffic will be directed to this address there. So to make this actually takes effect, we have to restart Apache. But there's also a way whereby you can actually make sure that there are certain times when you're running a web server in production, you don't want a situation whereby you make a change and that change brings in something that breaks the system, and then you have to start debugging once you've gone offline. Apache provides a way of how to test that if you've entered the correct values within your virtual host. A way to do that is to use Apache CTL, then you put -t. This will test your configurations without actually loading them into memory. This will just go through your SSL configuration and tell you the response. Have you entered the correct values? Is everything okay? If something fails, it will actually give you feedback. That way, you know before you actually restart your Apache daemon to know that, okay, everything is okay, or I have messed up on something and I need to change that something. So this is what Apache CTL -t does. The -t is a flag for test. So right now it's actually testing, and as can be seen, it doesn't really retain anything. So essentially everything is just fine. So at this point, we are safe to now restart our Apache daemon. To do that, I'll use systemctl restart httpd, which is the Apache daemon. For people running on Ubuntu, HTTPD is just called Apache 2. So for those, you can actually just use the Apache 2 and then it will work. So everywhere where we're using HTTPD in CentOS, for Ubuntu is different. You can use Apache and then just put a number 2 at the end of it all. It's one and the same thing. All right. My computer is kind of lagging. I'm running a VM. I think I'm running low on compute resources, but otherwise it should have retained by now. Let's see how this plays out. It's taking its sweet time to complete. Right. Okay. So there, our Apache has now finished. So just try to use scale to now say example.com, and there you can see, like if I say example.com, I'm getting an HTML page which is saying hello world, hello CentOS. So to actually verify that this example.com, which has given me this HTML as output, I can actually go to the file where it's resolving to. If I look into my configurations here, then var www.html. So let's go and look at the HTML that is in there to see if it actually matches with what I have here. And then open the index.html. So as you can see, this text which is in here is essentially the same text that we've actually gotten after using curl to resolve to this example.com, which is this. So this is essentially how you configure Oasis Apache to work as a web server. But there's also another use case for Apache, which is not really widely used, which is using Apache as a proxy. Proxies are normally, whenever people are using proxies, a huge chunk of the time, they use things like Nginx because they are lighter and stuff. But that doesn't mean they are the only solutions you can use. Even Apache can take in that, can do that job. So how you do that? It's a similar thing where you set up all those the virtual hosts and the likes, but there's only one single part that you change. So to show that, I use the same file we created, the example.com.conf, and now this time you'll name it, let's call it that, and then let's just call it www.example.com.conf. So we copy that, let's just edit that. Now in this case, instead of having a document root, which we have if you're having a normal server, for proxy servers, you use what is called proxy pass. So here you put up proxy, then you put pass, which essentially means it's going to get all the requests that is going to come through this address. Let's also put a different address. Let's say on www.example.com. So all traffic that comes through www.example.com on the top level domain will be redirected to another machine. It can be another machine. It can be just a web service running on the local machine. In this case, we want to redirect this traffic to example.com. So what we've actually done here is, instead of actually setting a directory here, we are saying if a person enters www.example.com, send them to this address. But when you look at this address, it's the same address that we had created initially, but in that case, we had put in a document root. The reason why I'm showing this is just to show you how proxy servers work. Because a proxy server is just a machine that sits and then captures requests and then redirects them to another computer. Hello? Is there a question or any contribution? Hello, Santos. Welcome. Hello, team. Are we together up until this point? Can I proceed? Hello, team. Can I proceed? Or are there any concerns or questions? Hello? Am I audible? All right. Thank you, Santos. That's what is asking us on what we're doing if we can proceed. Okay, thanks a lot, Santos. Santos confirms that you can hear me. I just wanted to get the words from the other people who've been listening on our conversation, who've actually been part of the meetup from the beginning, if I can proceed up until this point. Anyways, I'll continue. Let me just, okay. In a different session. What do you mean they're in a different session? Okay. Mhm. All right. I think at this point I'll proceed. We've basically just created a reverse proxy, which essentially takes in all traffic that's coming through www.example.com and then takes that to http example.com. Now, when you look at that, we already have a file that is saving example.com. So we are basically pointing to the same address. So the logic behind this is essentially just to showcase how you can use a proxy server. So before we can actually use it, we need to add this to our host files as well. So also do that so that it saves 127.0.0, which is the local loop.ip, which resolves to this same machine. So we are saying if somebody enters example.com, like www.example.com, take them to that address, and then when you take them to that address, the virtual host that is responsible is this. And then this virtual host doesn't actually save any content. Instead, it captures whatever request and then redirects it to another address, which is this address. But then this same address is sitting on this same machine and it's being controlled by another virtual host, which is this one. So when it hits this virtual host, it will now save the content that is in there. So to show how this works, we will now have to restart our Apache. So let's just restart Apache so that the configurations that we put in www.example.com can take effect. The reason why we have to always restart it is Apache doesn't constantly keep on checking files. the files that it keeps in memory are loaded the moment the process starts. So once the process starts, it doesn't pick up any new files. For you to make it pick up the files that you've made changes to, you need to restart it. Hence the reason we are restarting every time we make or add a new virtual host to the machine. So this is essentially what I'm doing right now. And like I said earlier on, my PC is kind of slow for some strange reason. So yeah. Anyways, we'll get through this. All right. So now it has returned, and there it says there are no errors. So let's just try to see if we are able to now resolve to this site, which is www.example.com. And there we go. www.example.com is also able to resolve, and it's giving us the same address that we had put here. So the two configurations that we've actually done for both a normal both a normal virtual host, which we had put in example.com, and I was pointing to a document root saved in there. We tried it initially, it was working, and then we went on to create another one, which was a reverse proxy on www.example.com, which was basically pointing to another, which was basically just pointing to a URL that was now finally handling, which was now handling the final request. So on Apache, that's really as much as I had to share. So if there are any concerns, questions, or any contributions, now is the time to bring them up before we proceed to the next chapter. Good day, welcome, sir.
Thank you. Thank you.
All right. So today's session was about Apache and Docker. We have just managed to conclude on Apache, so we are now moving to containers. But just a recap of what we've actually done. Um, we started by first creating a virtual host, which was kept in a file called example.com.conf. Essentially, here it only had a few parameters. These are the only necessary parameters. You can add a lot more, but those are for for when dealing with advanced features, or you need to use other modules of Apache. But for now, it was essentially just creating something that will save some web content. Here we had created the server admin to be that email address. We had put in a server name example.com, so that whenever a person enters example.com, it resolves. So it's resolving to the HTML files stored in that directory. And then to actually make sure that this computer is able to resolve example.com and point it to the right server we want, we had created in the host file, we had created a mapping to point to the local host machine. So as you can see, there's this local loopback IP, which is whenever a person enters example.com. So it's essentially going to the same machine. So if you look at that, if somebody goes on to this URL, I'm using the terminal, but you can also, this is this that can be done from a browser. Somebody enters example, it resolves to that address. It gives us this HTML content. Then if you look at the actual HTML content that is in this file, which we have in here, that's a response we are getting. So it's a similar thing that we also did with the other one, which is www.example.com.conf. Now in here, this is a reverse proxy. Now a reverse proxy is essentially just a server that captures requests and then transfers them onto another server. So this is what we are doing at this point. We are capturing all responses that are coming through www.example.com and then channeling them to that was the start address. Then this address is the one that we had initially created. So we had initially created. So essentially we are just showing how one can use Apache as both a forward saving server as well as a proxy server. So even using the same www.example.com would resolve to the same file, because our proxy server is pointing to our initial virtual host that we had created that is saving content on example.com. So this is what we've actually done so far in terms of configuring Apache virtual hosts. So now we are moving on, unless there are any questions or concerns with where we are right now. So I've actually stopped sharing my screen. I'll open something else. So unless there are any questions, queries, or concerns, I think now is the time to ask before we move on to something else.
In terms of proxying, that config is just for plain text, eh?
In terms of what do you mean? Sorry, repeat your question.
Well, if you were to do, I mean, this example or both examples for both the
Yes.
forward and the proxy, they're just for plain. You will not look at SS at the secure side. Eh?
No, it was just a plain HTTP. I did not tackle HTTPS.
Okay.
All right. But essentially the configurations are the same. Only with HTTPS, you would need to change the port from 80 to 443. Apart from that, you also need to point them to a directory where you have your certificate files. That is both the key as well as the certificate file. And some certificate authorities also provide a third file, which is a signing file. So it depends with your configuration. So yeah, I don't know if I've answered your question.
Yes, yes, yes.
All right, thanks. Any more questions before we proceed? All right. Since there are no questions, we now proceed to containers. Um, the topic will focus was on what is a Docker. It's a container that we're going to talk about. We're basically just going to talk about from scratch. I'll change the machine. Initially, I was using CentOS, which was running in a virtual machine, but there I do not have Docker installed. So instead, I'll run on the local machine that I'm using for this chart. This is Linux Mint, which I'm using currently. So one that I'll now, let me just share my screen, just a moment. Right. Please confirm, are you able to see my screen?
Yes, I can see it.
All right, thank you. Okay. Just try to zoom in a bit. All right, let me just, okay, move out of there.
Arthur,
Hello.
this topic is quite a tricky one in the exam. So I
Yes.
think start step by step from installing the container and how to configure it, and make sure that when you reboot, the container
All right.
still remains intact.
All right. Okay. The only part I will not talk about is the part for installing it.
Okay,
Yeah, but I'll start from what is from scratch.
all right.
All right. All right. Thanks. So, a container is essentially just an abstraction layer. It allows you to run application within a confined environment. So what that means is instead of you setting up a machine, putting your web server software and doing all the other deployments, that can actually be handled within within a confined space, which is just, and then that same confined space is also isolated from the underlying host machine. It kind of works in a similar way as virtual machines, but the difference is, unlike virtual machines, containers are very light, and the reason they are light is they do not have everything that a complete operating system needs. They only have the necessary files to run the application that they are built for. So in this case, I'll actually use some open source project. This one, the project that I'll use to build a container is one that is you can find on the Living Open Source GitHub page. It's what's this we called it? It's called Meetup. So So if you want to really like build it yourself, you can also follow along. This source code is available there. It's a public repository. So containers, how they work is there was this one concept you also have to clearly understand is the difference between a container and an image. An image, you can think of it as the raw file, the disk. When the versus when you are just pulling, when you just pull the file on your machine, that is an image. But once you run it, once it's running, when it's in a running state, it's now referred to as a container. So really, there's a difference there. So when you say something like Docker images, this is a command that you use to list the images that you have on your machine. So how containers actually work is every time you build a container, whether you're pulling it from Docker Hub or you're pulling it from other repository, or even if you just have it on your local machine, that container will be added to your list of images. So when you type in Docker images, you'll be able to see all your images. Now, like I said, an image is basically just a raw file that will allow you to build on top of that image or deploy that image so that it can be used as a container. To, so to view the images that you have on your machine, you enter this command, which is Docker images. So for you to now the other thing I talked about the concept of containers. Now for you to see the containers that you have, there's a different command, which is Docker PS. The PS is for process. So you're essentially looking for containers that are currently running. So we can say Docker PS, or you can say Docker PS dash dash, or to list all the containers that you have running. Now, when you put all, it will also include containers that are both running and are dead, as well as containers that are running and active. What I mean by dead is there are times when you're running a container and then it exits. Maybe it crashes. Like if you can see most of these containers on top here on my machine, all these did exit. So they are there because they're in an exit state, but versus they can be removed. But then you can also see there are certain containers down here which have been running for 10 hours now. Yeah. So those are some of these are the two commands that you use for checking either images or containers. Containers are the ones that are currently running, and then images are the files that you have on disk that you can use to build on top of other stuff. So um, these are the two commands, but to get containers, there's also a way you can get them from Docker Hub. Use a command docker pull, which is docker pull, and then you put the name of the container you want to pull from from Docker Hub. It can be maybe say I want to pull the Alpine container from Docker Hub, so I can just say docker pull and then I put Alpine. This essentially will go to the Docker Hub and then pull this container. Now this will also depend on how fast your internet is and other stuff. So because it uses internet to pull these containers. But if you have it locally on your machine, it doesn't even take time. It will pull the one that is stored on your machine and use that cache. That is the goodness with Docker. I'll cancel that. That was just for showing. So that is one way of doing things. Now we are going to talk about how to create a container using a file. Now that file is called a Docker file. Please do not really pay much attention to all these files that are here. They're basically just some source code for some web project. The focus should be just on this file, Docker file. So to create containers, you always create a file called Docker file, and please pay attention to the way it's spelled. It always starts with a capital D and it has no extension. So do not put anything like txt or dot whatever. It's just Docker file with a capital D. So let's look at the content of this. So we can say vim Docker file. Now, this container is versus when you look at on top here, it has a from command. So whenever you're building a container, you start from a container image. Now, a container image is like I had explained. This is a raw file that you have on disk from which you can now build the actual containers. In this case, I'm getting the node container, the version 8. So let me just show you something before I go there. when you do things like Docker images, it will give you a response like this, where you're able to see the container name, like in this case, there's Alpine, and then there's also another tag here, which is called latest. So the latest is also a tag that indicates the version. Like in this case, I've got my SQL container, and then the tag says 5 because I'm using version 5. So if I put this inside a from statement, it's going to be from my SQL. I'll put a colon here and put a 5 to indicate that I'm getting the MySQL container version 5. So when we go back to our Docker file in here, that's what we are seeing. Node, then there's a full colon, and then there's 8, because I'm using Node.js and I'm using version 8 of Node.js. And then there's this command that you're seeing here as build, which is just creating a variable to use for this container here. Now I'm thinking, this is a multi-build container, which is something that I kind of feel like it's kind of will cause confusion. Let me see if I can find the other container which is much easier to work with. Just a moment. Okay, do I have a Docker file in them? Okay, let me just look for the container that is in here. Okay, right. Okay, and then this is a much simpler container to explain rather than that one, because that one is using a technique called multi-build container. So I'll use this one, which is a simpler one. So there's a from statement here, and then here, this one is pulling PHP, and then the version of PHP I'm getting is version 7.0. But this container I'm pulling is also got Apache. So whenever you go to Docker Hub, you can search for for this container. And by the way, there's a way of how you can search what container, what images are there on the Docker Hub. To do that, you do Docker search, and then you put the name of the search query that you want to do. So in this case, maybe I want to look for, say, the PHP container version 7. So as you can see, these are the results that I've gotten. So there are all these containers here. These are all containers that you can get from Docker Hub. So in case you know that you want to build something using PHP version 7, but you do not know the full name of the container, you can do Docker search, and then you put the name of the container you're searching for, and then you get that result. Then from here, you can use any of these names here, whichever suits your needs. And then there's also a brief description on this other side here. So yeah, so this is how you really get to navigate your way around these containers. So let me go back to the Docker file. So that's about the first file here. This file tells the Docker context. Go to Docker Hub, download this container image. After it downloads this container image, there's a run command. The run command tells the Docker that you have to do this inside of a container. Now, this PHP container that I have is built on top of Debian. So as you can see, this command here is the same command that you would use on a Debian based distribution. By Debian, I mean Debian itself, Ubuntu, Linux Mint, and every other Linux distribution that is part of the Debian family. So here we are only doing what is getting updates, and then what is installing wget as well as unzip. After we install these, there's another run command. The other run command, what it does is it uses wget, and then this wget is what we just downloaded here. Goes to that site, which is just a GitHub page, downloads that file, and then it unzips it in the current directory where it is. Apart from that, it moves everything that is inside the folder called web console and then it moves it to this directory, which is called var www whatever. If you are conversant with Linux commands, you can relate to everything that is going on here. These are commands that you'd normally use on just a normal Linux system. At the end of it, or there's also this command here, which is basically just deleting this directory together with its contents. So this is what this run command is doing. Maybe I'm moving too fast or anything. Are there any concerns up until this point? Are we together?
Yes.
All right, Santos says okay. I've also seen a yep from Hilary. Okay, so I'll take it. Everyone is okay, and but if you have any concerns, you can always say. Then we can review it. So that's what is we were on the second run command. Then there's a third run command. As you can see, these are basically just steps that you'd perform on a normal machine. But then we put them inside the file so that whenever you execute that file, all these commands are performed for you. And the good thing about it is everything is within the same container. So whichever machine you put it on, the container will run the same because the commands are doing the same thing, getting all the dependencies and all the files that are needed for that service you are running within your container. So this will run everywhere. So there's a run command here which is using sed. So here when you look at here, we're basically just doing some string manipulation, which is changing the value of user, the variable what is called user, which is a Unix environment, and then setting it to that value in a file called web console.php, doing the same for password, doing nonsense. So they're basically like string manipulations and making some changes. After we do all that, we're also renaming the file web console.php index whatever. So from here, you can actually tell these are basically the normal processes you'd go through when creating was just maybe say a normal web application on a normal machine. But apart from that, there's a command which says working directory, and then I've put home. Working directory is you setting a directory, like if somebody enters inside of a Docker container, which directory are they going to end up in? This is what working directory does. Now, aside from that, there's also a command. I've commented it out here because I do not need it, but in some contexts, you might need it. What happens is what you put as cmd is a command that will be executed inside of the container. So if what is this, like the way I've put PHP, this is essentially the same as going on the terminal, type in PHP, you leave a space, period / web console.php. So this is a way of just executing this file on the terminal. This is what this command does. So this is basically just a brief explanation of what this simple container in a Docker file does. So basically looked at the first step. But as I am going through, if you have any questions, concerns, you can always cut me through halfway and then we can explain further if there anything that you need. So now, at this point, we'll build the actual container. To build the container, you say docker build, and then you put -t, which means tag. So a tag is essentially the name that you give to a container. So we can say this lesson underscore terminal. This is essentially just a name that is taken. This image we're building will be called. You put a period to indicate that you're building this container from a Docker file, which is in the current directory we are working in. So you press enter, and then up until this point, you basically have to let Docker do its magic. So from there, you can actually say sending build context to Docker daemon, has done that. And then there are 5 steps in this container that we are building. Step 1, start by downloading PHP version 7.0, which has Apache from Docker Hub. So that's basically step 1. So once it's done with step 1, it will go to step 2 and all the steps that are there. But apparently, what am I getting? Okay, cancelled while waiting for connection. Timeout exceed while awaiting headers. Apparently my network is slow, so yeah, it's unable to pull that container from Docker Hub. But otherwise, that is essentially how you build a container from a file. So moving on, I've actually talked about how you build a container. Now let me talk about the normal commands that you actually use, how to run a container, how to actually enter inside of a container, how to check logs of a container. So to do that, let me just look at the containers that I have running to see which one I can use. So I can say -A to indicate that I want all the containers that are running on my machine. So which container can I actually use here? Right. Okay. There's container here called unitravel full colon v2. I'll use this one. So to this container, to actually, let me first show you how to actually run a container instead of me just playing around with that. In case you have one that is just within your images, so Docker images, just to list all the images that I have. So to run a container, I'll run this container called Jupyter-notebook. So to run it, I'll say Docker run to indicate that I want to run it. I'll put -D to indicate that I want to run it in detached mode. Detached mode means do not display the logs on the terminal. Run them in the background so that I can use the terminal for whatever that is I want. Then you put -P to indicate that you want to do port mappings. Port mappings essentially mean the container inside the image has got ports on which it's listening to, but you can also map it onto the local machine to use different set of ports. So in this case, I want this container to listen on port 1001, but I know inside the container itself, Jupyter listens on port 8888. So what I'm telling it here by saying -P and putting this is, inside the container there is this port, but on the local machine, this port might not be available. So instead, I want it to use this port. That is what that command does. Apart from that, I can also give it a name that it can use to show. So I can call it just say my Jupyter. So I'll call it that. Apart from that, one thing that they also like in the exam is to say you have to make sure that this container runs whenever, even if a machine reboots. So to do that, there's what is called restart. You put restart and then you give it always. This essentially tells the container every time this machine reboots, run this container with these same configurations that I've given it. So that is what I've actually done. There are a couple more commands that you can actually pass onto it to make it even more dynamic. But for now, we'll end here. Now to end, you also, at the end of the command, this is where now you actually tell it which container image are you going to use to run this container. So here we've put docker run to say it's detached mode, -P to indicate our port mappings, -- name to give it a name. This is optional. Then there's -- restart always, meaning it should always restart even if we was to switch off our machine and then switch it back on. But then what container are we talking about? We have to call the container. This is where you now use this container, which is in the images file. So here we'll put Jupyter dash notebook. Then you press enter there, and then you let now the container engine do its magic. It will give you that hash value, which is a representation of the container instance. So if everything goes well, we should be able to get our terminal back, and then we should be able to use this container that we have just instantiated. So there we go. It has returned. So we have actually now run a container. So if we say docker ps, just a moment, let me just attend to something. I'll be back shortly. Just a moment.
Are we
Okay, all right.
sleeping?
Hi, Santos. Okay, I'm back. We can continue. Right. Just after that, let me just do docker ps to view the containers that we have running. So if you look at the container, the one that's on top here, we have Jupyter Notebook, which is the image, and then the name that we actually gave it, which is My Jupyter there. And then it will also tell you created about a minute ago, and it has been running about a minute ago. So now we have this container, but how do we use it? One thing you know about Jupyter is it has, you have to enter a string that you are given on the URL. Now that string that you have to enter in your browser for you to make it work is found inside of the logs. But if you remember when I created this container, I created it using this command, and I put in a flag called -d to indicate I want to run it in detached mode, meaning the logs will not be shown to me on the terminal, but I actually need it for this container. So to do that, you can either log inside the container or just display versus the logs without actually going inside of the container. Now, Docker provides you two ways of doing that. The first one that I'll show you is how to get logs from a container whilst you're outside of it. To do that, you can say Docker logs, and then you say the name of the container. So in this case, the name of, by the way, there's a difference between a container name and a container image. Please, that is something that you need to pay attention. If you look at here, there's image and then there's name. Image refers to the raw file. So an image, you can have one image and then from one image have multiple containers. So whenever you're referring to a container, you use the name, which is here. If you can't use the name, you can also use the container ID, which is that. So that I just wanted to make that clear. So to view the logs, you can say Docker logs, and then you say the name of the container we want. The name of the container we want is called My Jupyter. So you do that, and there we go. It gives you the logs. These are the this is more like entering inside the container and then typing tail. But there are instances when you want to see logs in real time inside of a container. To do that, you pass in the -f flag, which means follow. So like this, every time something happens inside of that container to give you some output, you'll be able to see the logs fly by in real time. So let me cancel that because I'm only interested in this URL here, because this is a URL I was telling that was for you to run Jupyter, it gives you some form of URL that you need to use. Now, if you remember, another thing that you also need to pay attention is it's listening on port 8888. But just clear up there. But if you remember, when you go back to this command here, we said all the traffic that's listening on port 88888 in this container should now be put on 1001 on this host machine. So you also need to pay attention to that. So let me just clear up that. So when you go in our logs there, we copy this URL, but this URL will not work on our host machine because we are not inside of a container. So we need to change. We need to replace this 8888 and put the port that we had mapped it onto. So I'll open a new tab here just to show you that this container is actually running. So if I use the 8888 that I got there, let's see how that works. So right now it's just loading. The reason it can't resolve to this exact host. So we can actually wait it until forever, but yeah, this is not going to work because we had put that 888 inside of a container. But on this machine, for it to work, we have to replace it with that 1001. So when you press enter there and let it load, and within a short space of time, there we have it. We have our web app running. So there, that support is listening on inside of the container. Now to actually show you the how Docker logs -f works, whereby you can actually see the logs fly by, let me just try to create something. If I create some file there, and then go back here, saying creating a new notebook, as you see, once those logs are now moving because there's some activity going on here. Just saying that, yeah, and then you're able to see it. So that's how you follow logs within a container. Now, apart from playing around with logs as well as running containers, seeing what you're able to run with a container, you can also go inside of a container. So to log inside of a container, you use the docker execute command. So you use docker ex, which is execute, and then you pass in the flags, which is I for interactive, T for the terminal that we're going to use, and then you name the container we want to go in. Our container was called my Jupyter. And then apart from that, we also need to indicate the shell we are going to use. I'll use bash. So what this essentially does is, okay, what has failed? Execute bash failed. Okay, let me try sh. Okay, so there, the container I was trying to run doesn't have bash. So when I used bash here, it failed. So I've changed my shell to use sh. Sh has now landed me inside of a container. So right now I'm inside of a container. I can say ls, and that's a file. I can see this file here. If you remember, this file I'm actually seeing inside of the container is this same file that we had just created in the browser here, which is this untitled. So to actually verify that this is the same file, you can actually create, maybe just create a line within here and then do ls within the browser here. So I say ls and then see the output, this file here, which I'm actually seeing. This is good because this instance you are seeing on my screen is running inside of the container. This is the file, and this is the file we are seeing inside of the container. So this is how you enter inside of the container. So you can basically execute most of the commands that you can inside of the inside of the container, but some do not work. Like if I was, let me just go inside here and then say vim. I know some containers do not actually have vim. So if I say there, vim not found, because vim is not necessary for containers, and by default it doesn't come installed. So we cannot use vim because we're inside of a container. So that's how you actually enter inside of a container. So we can exit, come back to our machine. So we've exited our container. There we are. We are back onto our machine. Okay, so what have we covered? We've talked about how to use Docker images to see what images you have on your machine. Talked about how to use Docker PS to see what containers you have running on your machine. We've talked about how to use the Docker file to create a container, of which we did not do that because this requires a bit of more time as well as internet to download all that. But this is something that you can practice during your free time. Apart from that, we also talked about how to run a container, which we are done with that command. So, so apart from that, we had also done something else, which is essentially like entering inside of a container, which we did by typing in that command. Apart from that, there's also, we looked at the logs, which can be done by using Docker logs, and then you put the name of the container instance you want to check for the logs, and then it will give you the last 10 lines from the logs. If you want to keep an interactive log, and then so that you can be seeing the logs as they are written to, you can pass in the -f flag, and then you get that response. So I think this is our end here. This is all that I had to share. So if there are any questions, any queries, contributions, I think now is the right time to do that.
How do you stop a container as well as how do you remove an existing container?
All right. Okay. Thank you very much, Santos. So let's do that. The same container that we have, the same Docker PS, we list out all the containers that we have, and then the container we have is called my Jupyter. Like I said, when you're referring to a container, you can use its name, which in this case I can use my Jupyter, which is the name of the container I created, or we can use a container ID, which is there. Whichever you're comfortable with works. I personally prefer using names. That's how come whenever I'm running containers, I always pass in the name flag so I give it a name that I want. So to stop a container is just docker stop. You give it either the container ID or the name of the container. So there. So you say docker stop, and then you pass in the name of that container. And then at this point, you just leave it and let Docker do its magic. When it does that, that essentially means the container has been stopped. You can actually do Docker PS to confirm that the container is no longer there. So if you look at these containers that I have running here, it's not there. So it's basically, so stopping a container is just Docker stop. Now here's another thing. Whenever a container crashes, let me show you something. If I do docker ps minus a to list out all containers, I've got containers which are running, these ones here, but then I've got also containers here, the ones that are saying exited, because this crashed or something wrong happened, or there was some error. But then they are still there, so they sometimes they do take up a bit of your storage. So you might want to actually remove them. So how you do that is, like, even the versus this my Jupyter that we have, even though we stopped it, it's still showing here as exited. So it's not running, but it's there as a container. So you might want to remove it completely from your system so that it only remains as an image, not as a container. You can use either the name or the container ID to refer to it. To remove a container, you say docker rm, and then you give it the name of the container, which is that. So there it says, what is no such container, my Jupyter. So let me just use the ID, because it's refusing that container doesn't exist. So you use the ID, which is that one here. So copy that ID, docker remove is by the way, there are two things. There's remove. If I just said remove and then I put, say, my Jupyter like that, oh God, I'm removing a container if I do it like this. But if I want to remove an image, I have to put an I there. So there's a difference between the two. So to remove an image, you put an I, but to remove a container instance, you just say remove like that. So this is a container instance that I'm removing. So just by doing that, I've removed it. That's how come it has retained here. So I can do docker ps minus o. There you will not see any my Jupyter there. It has actually gone. So that is how you stop a container, and that's how you remove a container. Now, I'll also talk about how to remove images, but before I go there, let me show you how you can remove, like you have all these containers exited, but you no longer want them on your system. So how do you go about that? Well, Docker doesn't really provide you a way of doing it, but there's like a nice hack that you can actually use, which is basically just doing a for loop. So for I in, and then you enter a docker command for removing containers, docker remove, and then when you say minus qa, which essentially will give you all the running containers, but instead of giving you the containers, just give you the container IDs I had, and then you say do docker remove, because we basically just want to remove all the containers that are represented by the I flag, and then say done. So run that, and then once we've got some issue there. So syntax near unexpected for I in docker. Oh, okay. That's this L is not supposed to be there. It's supposed to be a semicolon like that. Let me just clear up everything so that at least it looks neater. So the command is supposed to be like that, and then here it's supposed to have a semicolon. Like that, this it will go through all the containers, removing all the containers that I do not have. So it tells me docker remove whatever. Okay, why is it failed? For I in, okay, there's that command, remove qa do docker remove, which is I that, right? Minus q is failing, so let me just say docker ps minus qa. So it's giving me all those containers. So why is it failing when I try to do it like this? Okay, for I in docker, oh sorry, it's not supposed to be there. It's supposed to be docker ps here, because essentially I have to first list all the containers showing the images and then do a docker remove on the second run there. So this will now work. So run it like that. So it will go through all the containers. And if you look at it, the first ones just retained without any complaints, but these other ones said, no, these containers are running, so they cannot be removed. So it hasn't removed them. So if I now do a docker ps minus o, it will show me only the containers that are running. The ones that exited have now been removed. So the ones that exited are no longer part of my system. They are long gone. Now I've shown how to actually remove containers, how to stop them as well as to remove them. But if I do Docker images, you notice that I still have Jupyter Notebook there. So what if I want to remove it from my system completely? This is an image. Okay, now I need this Jupyter Notebook. I use it for some other stuff, so I'll not remove it. Instead, I'll remove this other one I called Notebook because I don't use that one. So to remove a container, I say Docker. This is an image, by the way, not a container. Docker rm is for removing containers. If I want to remove an image, it's rmi, and then you put the name of the container. The name of the container we're looking for is Notebook. You press enter, and there it deletes the container. So you can now say Docker images, and Notebook is no longer there because it now has been removed. So that is how you stop a container, remove a container, as well as remove an image. So Santos, has that answered your question?
Yeah, very much.
All right.
Okay,
Any
thanks.
questions? Any other questions from the others? All right. If there are no questions, then we end here, unless there's anyone who has got something to say, something to share, something to add, or any other information that we versus the community might need to share. But otherwise, as for me, this is where I end. Unless there are any questions, I'll end here. So thank you everyone for giving me this opportunity to actually share with you some of the little things that I know about containers as well as Apache. So thank you for attending. Santos, please do us the honors of blessing the meeting.
Hello. No, I think I don't really have much to say, but yeah, just that to appreciate everyone who managed to join the meeting and the session. Actually, it was a great one. That's all I can say for now. Otherwise, yeah, everything went well. I don't know if anyone else has anything to say, but this is all I have. Yeah, nothing much. We can prepare for the next session, which is on Wednesday. I don't know. We'll figure it out tomorrow who will be presenting and what topic we'll present on.
All right, guys. From me, it's a good night. We'll see you on Wednesday. We'll keep chatting in the group.
Sure. Okay. Good night.
Okay, good night. This is a recorded session, so I'll share the link to the recording maybe in an
Okay.
hour. Yeah. All
Okay.
right.
Thanks.
Okay. Good
Okay.
night, all.
Okay. Good night, everyone.